Baozi Training lead code solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. We're here to help you land your next dream offer. See this cute little video we made 7 years ago. All right, so today we're going to continue to talk about the Google Code Jam 2020 qualification round. So if you actually been following us on those ones, you should already, at least the next time you could be in the real round, like round A instead of a qualification round. So let's talk about this problem. This problem is called parenting partnering returns. So there's a lot of descriptions, but essentially the problem is giving you a time range. So essentially, let's say the time range is start from a time and end from a time. And then you have two parents, they have to take turns to take look at the children. So if there's a way that two parents can finish all those tasks within this range, you should basically output one of the possible solutions, or else it will be impossible. So one way to describe this is if you have a kind of a timeline. This is timeline T. So what they define the problem is the start time is inclusive, and then the end time is exclusive. Remember, we use the solid for inclusive, just like the bracket like this, and then we use the halo one for not inclusive. So essentially what it means is if you have another task starting from this point, let's say this is 1, this is 100, this is a time, and you have another task from 100 to 200, it's not considered overlap, okay? So the problem becomes if you have like a task like this is the one task, and then you have another task, and let's say you have another, let's say if you have another task somewhere here, so you can have say C to work on the first task, and then you can have J to work on the next task, and then this one you could either be C or J, it doesn't really matter. So the possible answer could be say J, say C, or C, J, J, or if you start from J, it's another two combos of solutions. But if you have another task here, there's no way you can do this. You should output impossible. So at a first glance, this problem looks very similar to this lead code question, the merge interval, or whatever the interval question is. If you actually did a quick search, so this is a video I did 5 years ago. So come on guys, 6 dislikes. Anyways, take a read on this. So for solve those kind of questions, there are essentially two ways, right? So one way is you define this interval and then you implement this comparator method, which is sorted by the start time that somewhere you have to collection.sort the entire array. So everything is sorted based on start time. Another way is you model everything as a point. So I won't talk too much about this. So that way is essentially you model. So instead of viewing this as intervals, you view this as an array list of points, like a 0.1, 0.2, 0.3, 0.4, 0.5, 6, etc. And then this is once you model as point, it's very easy to do some kind of, is it overlap, yes or no kind of question, but you cannot really answer the interval question. So for this one, let's model everything as an interval. So essentially, you can define an interval that has a start point and an end point, and then you can sort based on the start time. So once you have that kind of concept, this problem becomes relatively simple. So all you need to do is you sort it, and then essentially you can just assign the task, right? So at first you can just assume nobody has task, you always pick C, and then once you pick C, so you should update the task end time to be the task's actual end time. And then when a new task comes, you're gonna compare, okay, this new task's time needs to be larger than C's finish time so that C can do it, or else it has to be larger than J's end time so that J can do it, or else you should just output impossible. The only small caveat of this problem is if using this method is just remember, because the original task asks you to output the original order, but once you sort all the array, so once you sort all the array, the task order is messed up. So that's why you also need to remember the original index. So what I did is, for this problem, So when I define my index interval, so I have the start and end. This is very usual. I also recorded the original index in here and then sorted by the start time. So as you can see, once I create the index, the interval, so I have the start and end time, and also I have the original index. So now I sort. So I have the initial value of the C's end time and the J's end time. C and J basically two persons. And then you loop through the array. So you are doing the endpoint comparison thing, and then always remember, right? So the result, you should want the original index to assign one value because it's sorted, right? So you want the original first task needs to be assigned to C if it matches this condition, or else it matches to J, or else else is impossible. And then at the end you output the array. So this method is relatively straightforward. So the reason I actually want to talk more about this problem is this can also be solved using a bipartite graph coloring problem. So what is a bipartite graph? So first of all, whenever you see all these kind of interval questions, as I said, there's two ways. Previously we talked about two ways. So one is you flatten everything into a list of points, and the other way is you model everything as an interval. And then actually the third way is to use the interval graph. So what this interval graph means is every interval looks like this, and then you can model each interval as a vertex in here. So the first interval A is a vertex A, and the second interval B is a vertex B. And then as long as A and B overlaps, so there's an edge between A and B, and then A and B and C overlaps, so the B and C, and A and B and C both overlap, so they have these two edges connected. So you have to write a method to convert this. So once you write a method to convert this, then the problem becomes, can you color this graph only in two different colors? How do you do that? I have the link here. It's actually very simple as long as you can write a BFS, which means you're using a queue and a hash map. This hash map denotes for whether this node is visited or not, and also remembers the color. So what I mean by that is, so let's say if you actually have a graph somewhere looks like this. So it's a undirected graph, something like this. So once you have this graph, you'll start with this. You'll say, okay, I have this node, and then you BFS, you pop this node, and also this doesn't need to be connected. You can have a node like this. If it has no children, everything's good. You just remove, pop it out. And then let's say you have this first node pushes in, and then you can color all the neighbors to be J. Everything so far is good, so pop it out. And then for this J, so C is already visited, you don't visit, but then you visit this node. You can visit this one. You can say, okay, this can be colored as C, but then this node is already colored as G. That means there's no way you can, there's a bipartite graph in this graph. So this is not a bipartite graph, and then you should return impossible. So the time complexity of this method is O V plus E. So the tricky part is how do you construct this, not tricky part, but then you have to write a function to convert this interval into an interval graph. That's it. The original method, the time complexity is O(n), because we just iterated. Oh, sorry. The time complexity is not O(n). I need to update this. It's actually n log n because we sort everything. We sort the entire intervals, right? And then after the sorting, n log n, and then we iterate through one by one using greedy. This is essentially a greedy method. Did I put it somewhere? Thought process, greedy solution, yes. And then the space complexity is after we sort, we put it here. We have a string builder to store all the intervals. So it's kind of like in terms of O of n, but we don't have extra. Well, we listed, so it's O of n. So I think that is correct because we have to have the actual result, and also we have an extra list to store all the list intervals. So I'll update this and log in time complexity. All right, thank you very much. If you have any questions, feel free to leave your comments below. Thanks a lot for watching. Bye.